All right, so welcome back to this one. In this video, I'm just going to go over these three examples of solving linear inequalities. And if you really want the introduction to this, I'll put up a link up above there for you, okay, to these linear inequalities. And here I'm just going to walk through the three examples to show you how to solve them. All right, so my strategy whenever I'm dealing with these linear inequalities is to first simplify the left-hand side and then simplify the right-hand side and basically put it into the linear form of a line, which is just the mx plus b form. So that's would have been step one. Step number two is to just simply move the terms around so that I can collect my like terms. And then step number three is to divide or multiply to solve for whatever unknown that I might have. All right, so let's get to it. So here's example one, and I'm going to walk through this one first. In this particular example, so what I have is, so step number one, I'm going to collect all my terms to put it into linear form. So on the left-hand side, so I'm going to simplify it, and I'm going to get negative x over 2. Now I'm going to get rid of that bracket. It's kind of unnecessary there. So this is what I have. On the right-hand side, there's nothing to do. I just basically have negative 2. And if you think about that as a line, it would have been just a flat line, right, at negative 2, if we had that. Now in here, so on the left-hand side, so what I would have is now I'm going to have negative. So the x's can come together. And now I have, so here is my, basically, it's like having a slope. This is your intercept on the left-hand side, so I have it now in the linear form that I like. Okay, so that's step one. Step two is I'm going to move the terms around. So I'm going to get rid of this because I just want to have my x on one of its sides. It's going to be negative 2 minus 2, which is going to be, I guess, so this right here is just negative 4. So I have this, negative 4, and then negative 3 over 2x. And here I have to get rid of, so I'm going to get rid of this negative 3 over 2. So I can multiply by the reciprocal on both sides. So I can do this. So 2 over 3, multiply by that. And then I would have to do that on the right-hand side as well. Now notice, because of the fact that I am doing this with a negative number, my inequality will switch. So in this case, what I'm going to get is x. Now it's going to become less than or equal to. And now this negative and negative cancels. And I'm going to get just 8 over 3. And that's my answer. Now I want to also draw this out for you in terms of decimals, or plot it out using decimals so that you can see. And I'm going to take it basically through this form right there because I have two lines. So let me explain that to you in that particular way. So if I bring out decimals in here, so you get a visual and understanding of what is actually happening. Okay, so here is, okay, my first line. So my line is negative 3 over 2. And that's x plus 2. So here is my line. That's my first line. My second line is just simply negative 2. Right? So this is what I have. And I'll put y is equal to negative 2 so that it knows that I'm plotting a line there. And this is what we have. And what we're asking for is the inequality in between these two. Right? So our inequality, so notice in here, what we had from that line is that my line, negative 3 over 2x plus 2, is supposed to be greater or equal to negative 2. Now, if you plot this, when is this true? Well, it is true, okay, so notice if I go all the way over here, that line is above, okay, so starting at the 2.66666, which really is the 8 over 3 that we found. So if I go back here, our answer was that x has to be less than or equal to 8 over 3, which is exactly the case here. And you can plot this out, so negative 3 over 2, x plus 2 is greater or equal to, I guess, negative 2. And notice that's the red that you see there. All right. So it means is that to the left-hand side of that 8/3, that is where our line, the line -3/2x plus 2, is actually bigger than the flat line of -2. That's the actual meaning if you wanted to think of it that way. All right. Now, let's take a look at our second example. In our second example, so this is what we have. So I'm going to copy this, bring this down. I'm going to move this up here. And now let's try to solve this. So again, so first, I basically simplify my left-hand side and my right-hand side and put it into the linear form. That's what I will have. So in this case, I'll have 3x. I'm going to bring in the negative. That's going to turn that less than. Bring in that negative in there, which is -2x minus 2. This is what I have. Now, if I collect my like terms within here, so this, and sorry, so this is 3. This is going to be 4x minus 2. So that's one of the lines. And then the other line is already in its mx plus b form. All right, so those are my two lines. So what I'm asking really is, when is this line, okay, for which values of x is this line smaller than this line? All right, and then I can plot that as well. And when we're going to do that in just a moment, but let's solve it first. So now I'm going to collect my like terms. So I'm going to bring the x's over to one side. So that doesn't change anything with the inequality there. And then I'm going to bring, this is going to be bringing the -2 from the left-hand side to the right. Now I have 6x less than, and this is 0. Now I'm dividing by 6. Now that's a positive number, so it does not change the inequality. So this will stay the same. And this is going to be x less than basically 0. So it's telling me that this line is going to be smaller than this line for all the values of x that are smaller than 0. Let's plot it on Desmos as well. So I'm going to plot this one on Desmos. Okay, so let's bring it out in here. Let's shadow these off. Okay, and let's take a look. So I have 4x minus 2 less than -2x minus 2. And notice, indeed, that's exactly what Desmos plots. Okay, so this is what we had. And the two lines on their own, so 4x minus 2 was one of the lines, and then -2x minus 2 was the other line. If I bring this out like this, so now you can see exactly when the purple line is actually above the green line, or vice versa, meaning the green line is below the purple line. And that was the inequality that we had. And notice that Desmos actually puts, I don't know if you can see that directly there, it has a dashed line because it's not equal to at that 0. All right, so that's another example and a super neat way to be able to see that. Here's the last example. All right, so there it is. Okay, so our last one. So this one looks complicated in some way, and some students might kind of freak out, okay, how to solve this. So here's our inequality, so worry about that at the end. So first, simplify as much as possible. So in this case, I'm going to take 4x. I'm going to get rid of all the brackets in here. I don't want these brackets. I'm going to distribute this in. Okay, so that's what we have there. Now, on the right-hand side, I'm going to bring this inside in here. Okay, so that's what we have there. Now, next, okay, I'm going to try to put this into basically linear form. So 4x, that's 5x. 5x minus 2x is 3x. And then -2, -4, so that's going to be -6. So that's one line. My other line is -5x minus 4. So that's my second line. And now, so once you come to this point, all right, so let's collect the x's together. It'll be 3x plus 5x less than -4. Bring the 6 over on the other side, which is plus 6. And that gives me, so that's a 2. This is an 8x. Dividing by 8 on both sides, it gives me x. And this is 1 over 4, which is basically 0.25. Notice the inequality does not change because we're not multiplying or dividing by a negative. And here for the last example, so let's plot it on Desmos. I'm going to turn these off. Okay, so let's plot that. So we had, let's maybe start with the actual lines. So this is 3x minus 6. It's one line. Negative 5x minus 4. That's the other line. And now you can see. So what it's asking us within here is when the 3x minus 6 line, which in this case is the black line, when is it, all right? So we can kind of see there, when is it below, right? So when is it below the negative 5x minus 4? That's what it's asking us. Okay, and you can see that visually, and you can also put that in here. So 3x minus 6, and it's going to be less or equal to, and it's going to be negative 5x minus 4. And you see that highlighted there on Desmos, and that basically completes the last example. All right, so Desmos is a super nice tool to visually see these things as well when you're working with these linear inequalities. All right, so I hope that these 3 examples were useful. Again, the only difference between solving equalities that are linear and inequalities that are linear is the fact that when you multiply or divide by a negative, okay, your inequality will swap. All right, that's what will happen. Now, that's not the case for nonlinear inequalities, but that's a video for another day. All right, take care, everybody. See ya.